Hi guys, welcome back to my YouTube channel. As you already know about myself, I am Nitya Shrivi, presently pursuing my education in Sri Venkateswara College of Engineering, Bangalore. Today my topic was to explain about critical points of a network system. First of all, what do you mean by network system? Network system consists of interconnected nodes and edges representing relationships. That is a collection of objects called vertices or nodes that are connected by lines or edges. Understanding the dynamics of this system is essential for various applications including transportation and communication. Critical points in these systems are indicating stability or instability in their behavior. Importance of critical point. Critical points helps identifying equilibrium states in network dynamics. The behavior around these points can inform system reliances and respond to prohibitions. Analyzing critical points allows for effective control and optimization strategies. That is, a point is stable if we stand close to the critical point and follows a trajectory. Basics of linear algebra. Linear algebra provides tools for analyzing vector spaces and linear transformations. Key concepts include matrices, eigenvalues and eigenvectors, which are vital in studying critical points. Understanding these concepts is fundamental for applying linear algebra to a network system. As we already know, formulas for vector, that is cross product of a vector, dot product of a vector, angle between vectors, and are useful to study the critical concepts of critical points. Matrices in a network system. Matrix represents the structure and dynamics of a network throughout adjacency and indecency matrices. The properties of these matrices such as rank and determinant plays a crucial role in stability analysis. Matrix operation can be used to drive system behaviors and relationships between nodes. There are three types of matrices: and undirected, directed and weighted. Undirected matrix are one whose diagonal elements are 0 and non-diagonal elements are not equals to 0. Undirected matrix, the matrix in which diagonal element and below the diagonal elements are 0 and above the diagonal elements are not equals to 0. Weighted matrix, the matrix is one in which whose diagonal elements are 0 and first row and second row is not equals to 0. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors reveals important stability characteristics of network system. The science of eigenvalue includes whether prohibitions will decay or grow over time. Analyzing the dominant eigen provides insight into the system's long-term behavior. Given a square matrix A, if there exists a scalar lambda and a non-zero matrix X, such as Ax equals lambda x power 1, then lambda is a eigenvalue and x is a eigenvector. If the eigenvalues are real and repeated, the critical points is either a star or a improper node. Stability analysis. Stability analysis assesses how a system responds to a small disturbances around critical points. Linearization techniques can be employed to simplify complex network dynamics. The stability of equilibrium points can be determined using the Eigen's analysis. Stable means if A greater than 0 and AC minus B square is also greater than 0, then the point is said to be stable or a local maxima. Unstable means if A is less than 0 and AC minus B square is greater than 0, then the point is said to be unstable or a local minima. Saddle points means if AC minus B square is less than 0, then it is said to be a saddle point. There are three types of stability analysis graphs: root array, root locus, blot points. Types of critical points. Critical points can be classified as stable, unstable and saddle points. Each type of critical points has unique implications for system behavior and stability. Understanding these types aids in designing reliance and network systems. Saddle points means if A is greater than 0 and AC minus B square is also greater than 0, the point is said to be a saddle or a local minimum point. Unsaddle means if A is less than 0 and AC minus B square is greater than 0, then the point is said to be unstable or a local maximum point. Saddle means if AC minus B square is less than 0, then the point is said to be a saddle point. If f dash of C is equals to 0, then the point is saddle, and f dash of C is equals to 0, then the point is said to be a local maximum or a minimum point. Applications in network system. Linear algebra methods are utilized in various fields such as transportation, ecology, and information networks. These methods helps optimize network performance and enhance system robustness. Case studies demonstrate the successful application of critical points analysis in the real scenarios. There are many applications of a critical point such as transportation, communication, ecology, etc. Conventional techniques. Various conventional methods exist for finding critical points in a network system. Techniques such as power method and QR algorithm are commonly employed. Implementing these methods can aid in the real-time analysis of dynamic networks. There are 4 types of conventional thinking: decomposition, pattern recognition, algorithm design, abstraction. Challenges in analysis. Analyzing critical points in a large complex networks possesses significant challenges. Conventional complexity and the presence of noise can uprise critical behaviors. Developing robust algorithm is critical for accurate critical point identification. Future directions. Research in this area is expanding to include nonlinear dynamics and complex network structures. Machine learning techniques are being integrated to enhance critical analysis. Future studies may focus on adaptive networks and their critical behaviors. Linear algebra is essential for understanding critical points in a network system. Eigenvalues, eigenvectors provides insights into stability and system dynamics. Applications across various fields highlight the importance of analysis. We already know a lot about a linear algebra, that are eigenvalues, eigenvectors, etc. Thank you guys for watching this video.